So as we've seen, when we declare our variables, we give them a type. And the most fundamental types in Java are what are called primitive data types. And these are the data types that are actually built into the language. Now, when you hear the term primitive data type, you may think there's something kind of lowly about them, something kind of, less than modern about them. But that's not true at all. Primitive data types are actually very important. They're really the foundation of all other types that we use in Java. So that's that kind of strong foundation that we're going to build on for any other data types we use in our programs. Now, there are four categories of primitive types in Java. There are the integer types, floating point, character, and boolean. So let's look first at the integer types. Now, there are four different integer types, but the difference in them really is just the size of storage that they take up. But that difference in the size of storage they take up affects the range of values that can be stored there. Right? So the smallest integer type is the byte type. Right? So it takes up 8 bits, so it can only store between -128 and +127. And so we see when we just declare a variable of type byte, and we just assign the integer literal to it. Right? So here we have a byte number of English letters equals 26. The next large integer type is short, which takes up 16 bits. Right, lets you store between -32,000 and +32,000. Right, use it exactly the same way. So we have here short feet and mile is 5,283. Probably the most commonly used integer type is the one called int. Right, that's a 32-bit integer, and being 32 bits lets us store between -2 billion and +2 billion. And then the big integer type is what we call a long. Right, that's a big 64-bit integer, and you can see it can store huge values in it. The key thing to notice though is that when you use a long literal value, you have to put that capital L at the end of it. Now, Java also has floating point types. Now, the floating point types conform to the IEEE standard for floating point, and that may or may not be meaningful to you. What it really comes down to is that floating points allow you to store values that have a fractional portion to them. Basically, it supports positive, negative, and zero values that have some fractional portion. There's a lot of nuances to the way floating points work, and they're kind of outside the scope of this course. But I've got that URL on the screen there for you. If you want to know a lot more about the details in terms of how floating points work and kind of the oddities of them, I encourage you to check that out. But basically, we have our two floating point types in Java. First, we have the float type, which is a 32-bit floating point value. Notice that when we use the float type, we have to put the F at the end of any constants for it. So when we declare this float called miles in a marathon, we say 26.2 F, saying it's actually a floating point value. And then we also have double, which is a 64-bit floating point value. If you just use a literal that has a decimal in it, the compiler assumes it's a double, but you can also make it explicitly a double by putting a D at the end. So we look here, we have double atom width in meters. You see that 0.0001 D denotes that that is a double literal. And our last two primitive types are character and boolean. And a character, or the char type, stores a single Unicode character. And basically, you denote the literals of these by just using single apostrophes or single quotes around the constants. Right? So if I say char, the regular U equals, and I put apostrophe U apostrophe, that assigns that char into it. Now note, this is different than strings. We'll talk about strings later. Char is just a single character value. And because the char type supports Unicode, you can actually specify any valid Unicode character in there. So if you want to assign a Unicode character that you don't have on your keyboard, you can use the Unicode code point by using that /U notation. Right? So you see here I've got this char accented U with the apostrophe /U 00DA. Says that that is actually a U with an accent on it. And then finally we have our Boolean types. Right? Boolean types store true and false. The literals for that are true and false. So if I say Boolean, I love Java, equals true.